This video will discuss how to generate individual vibe locations along a polyline for use in vibe navigation. We will also cover how to compare the original center of gravity to the newly designed center of gravity. To begin, we will need to generate coordinates at each endpoint along the polyline. To obtain this, start by first loading the polyline shapefile of interest into QuickMap. Next, go to the Layers dialog. Right-click on the file, select Send Objects to File, and specify a name and format for the coordinate file to be generated. This will generate points at each azimuth change along the polyline. Next, we will need to generate a template offset file for purposes of defining spacings between individual vibes. To do this, go to the Image menu, select Template, and then Design. To simplify this process, we can use the Helper tab to generate the offset locations. Begin by defining values for what inline and crossline represent between each cell on the grid. Then, click on each box to generate points. In this example, we will generate 4 vibe locations per point, with the first vibe being 10 inline, the second being 5 inline, etc. Once complete, click Close, and the offsets will appear in the order in which they were selected on the grid, with the appropriate spacings applied. Save the TPL and close the dialog. Next, in Quick Load, open the Crooked Line window from the Generate menu. Browse to the coordinate file of road vertices created from the shapefile in QuickMap. Next, define the parameters at the top of the dialog, including starting station number, station spacing, increment, and descriptor. Then, save the CRK file for later use. Once saved, select Process to save the coordinates as a QLD. This will generate points over the road polyline in increments defined by the station spacing. Finally, with the coordinates loaded, go to File, Update Database to export the newly generated source preplots to the database. Once the database is populated, open GPSeismic and build a query to extract these points. In this case, we will use the preplots source query. With the query selected, go to Query A, Seismic Report Vibes. Browse to the Vibe TPL, and place a check next to each offset you wish to generate points for. You also have the option to assign a unique identifier to each vibe by defining a station suffix. If using suffix identifiers, check the Place Suffix in Descriptor box. For this exercise, we also want to check Use a CRK for azimuth for these points to be generated along our CRK file. Select OK, and browse to the CRK file. Finally, specify a name and format in which you wish to generate the new coordinate file for individual vibe locations. Next, we will generate a buffer around the road polyline to offset points into. Keep in mind, shot points could potentially be generated on or near the edge of the buffer. To ensure vibes can truly shoot the generated point, it may be best to account for half of the width of the vibe or more on each side of the road, creating a buffer narrower than the road. To generate a buffered road, add the road shapefile into QuickMap. Next, go to the Layers dialog, right-click, and select Send Line Objects to XCO. Specify a name and a buffer for the new XCO file. With a buffered XCO, go to the search menu and choose XCO to shape. Using the buffered XCO file as the input, we will generate a buffered shapefile of the road. If you load the new buffered shapefile, you will see a 2-meter buffer on each side of the road has been applied. For the next step, ensure the buffered road shapefile is the uppermost file in the layers dialog. Then, from the search menu, choose Prepare Raster or Shape Image. This will define the buffered shape as an exclusion zone, which we will later convert to an inclusion zone. Next, open the coordinate file containing individual vibe locations generated in GPSequel. If we zoom in, we notice that not all points fall within the specified road buffer. Our next goal is to move all points within the bounds of the road buffer using auto offsets. First, go to the search menu and select Search Now. This will convert all points currently within the buffer to hit. Next, go to the Miscellaneous Settings dialog and select the Automatic Offsets tab. Here, we want to set up a radial offset search. To perform only radial searches, set inline and crossline values to 0. Set a radial tolerance of choice. In this example, these settings will perform a search every 1 meter at 45-degree intervals. For more information as to why this is, see the help file. Next, we need to define a minimum separation value to ensure points are not offset if they are within the defined range of existing points. For this example, we will use 4 meters. Finally, turn on the inverse logic to place points within the buffer rather than offsetting them outside the buffer. Once the offset parameters are set, perform a polygon capture around all points requiring offsetting. Before closing the polygon, right-click and select Auto Offset. Then double-click to close the polygon. All points, which can be offset using the defined criteria, are moved and changed to hit status. Any remaining primary points still fall outside the buffer. If we zoom in on the first point, we see that it could not be offset because it extended beyond the road. For this example, we will manually move this point into the road. Go to the Miscellaneous Settings dialog and select the Lines and Labels tab. We want to define a value for the Move Halo radius. For this example, we'll use 5 meters. Next, launch the Move tool and click on the point to be moved. We now have a 5-meter halo around the point. This will help us move the point roughly 5 meters away from other vibe locations. Once the point has been moved, press Escape to exit the move process. We can check this move and its distance to the nearest point by using the Ruler tool. If you wish to redo the move, go to Edit, Undo Last Move. For the remaining points, we will refine our auto offset parameters in order to provide greater flexibility where points can be offset. Open the Miscellaneous Settings dialog and select the Automatic Offsets tab. This time, we will choose the maximum values for the radial tolerance search parameters. Note that, doing so will require a longer search per point, and therefore it is best to first search using the default tolerance settings. We will also adjust the radial tolerance to 11. These new settings will search every 0.275 meters in 11 and 1/4 degree intervals. For more information as to why this is, see the help file. With the new offset parameters set, perform a polygon capture around all points requiring offsetting. Before closing the polygon, right-click and select Auto Offset, then double-click to close the polygon. We see that both points have now been offset into the buffer. If we zoom in on one of these points, we can confirm the new position of the point and its proximity to the nearest point. In order to confirm all points have been placed inside the road buffer, we can lower the pixel size of the points for visual confirmation, or open the summary dialog and verify the number of primary points. If 0, all points fall within the search zone. Once all points have been offset, go to File, Outputs, and save all individually offset vibe locations to a coordinate file. Once saved, perform a polygon capture around all points. Before closing the polygon, right-click and select Convert to Primary. We want all points to be converted to primary so we can generate new center of gravity locations for each point on the secondary layer. Next, go to File, Outputs, and send all points to a spreadsheet. Once loaded, go to File, Average Duplicates for Secondary Layer, and select No. If we zoom in, we see that we now have a newly calculated center of gravity location for the offset vibes. With the new center of gravity locations on the secondary layer, go to File, Outputs, and generate a coordinate file of these new points. Finally, in a new session of QuickMap, load the original crooked line points generated in QuickLoad on the primary layer, and the new center of gravity locations on the secondary layer. Then, go to File, Compare, Offsets, to perform a comparison on matching stations. Then, go to File, Outputs, and select the Offsets Report icon, and select Yes. Once loaded, perform a sort on the Offset Range field to determine the largest offset from the original to new center of gravities. If we move the dialog box to reveal the points, we can highlight the record with the largest offset and press the red box. This will indicate where on the map the point is located.